Hello everyone, good morning. Welcome to this new session on electromagnetic fields and transmission line. Myself Dr. Sohail Rana, and today we are going to discuss about the magnetic field in static condition. So this chapter we are going to start as the name of this chapter is magnetostatics. In previous chapter we have studied about the electrostatic. Now we will see what is the difference between magnetostatic and electrostatic, and then we will proceed with magnetostatics. So what is meaning by magneto? Magneto relates with the magnetic field. So this is a term which is related to magnetic field. This is the first thing. Second, what is meaning of static? Static means which is in rest, not moving. So we have to study the effect of magnetic field when these fields are in rest. And what is the meaning of field? Field is any place where number of forces are working together. Number of forces working together is nothing but a field. So in electric field, electric forces were working together. In that we have seen the electric field intensity and electric flux density, where the force which were constituting a field. Now in this chapter we have to study the field related to magnetic field. Now let us compare few more parameters between electrostatic and magnetostatic. So this chapter is combination of electrostatic as well as this complete subject is nothing but related to four parameters. Which are those four parameters? First is capital E, second one capital D, third one capital H, fourth one capital B. Now these are four vectors. That's why we are putting bar on this alphabet, where E is electric field intensity, D is electric flux density, H is magnetic field intensity, and B is magnetic flux. So out of these two are related to electric field. Now electric field will have the Ohm's law. In that, say we will have if we consider a current, then there will be current I we consider in electric field, and remaining two are the magnetic field. In that, if we consider a magnet, then we consider phi in place of current. So in electric field we can say there is a current I, in magnetic field there is a flux phi. Then there is relation between D and E. E and D both are related with one relation, that is D is equal to epsilon E, and similarly H and B are related with one relation, that is B is equal to mu H, where epsilon is the permittivity of the medium and mu is permeability of the medium. These are nothing but how easily the medium give them permission to flow across them. For example, if you are calling someone from one mobile phone to another mobile phone, so this signal should cross from various type of regions. Like it may need to cross from free space, that is air, or it may need to cross some wall. Inside wall there may be material like steel and all, so those may be the conductor. So there may be some fields where related to electric field. Few materials will have magnetic field. So if the signal is crossing through electric field, it will have to take consideration of the permission of mu epsilon, and for magnetic field it will consider the mu. So we have to consider the values of these parameters. For example, for air, epsilon r relative permittivity we consider as 1. Similarly, for different materials like dielectrics, there may be mica or glass, they will have different value of epsilon r. So how easily they will allow, or how difficultly they will allow to cross these signals across them. And if we see D, what is D? D is density. Any density we can write as cos per surface or area or length. So as density increases, the area decreases. So from that, in previous electric field we have seen D is equal to, what is D is equal to? It is cos, that is charge, or the flux was the cos of the D, and inversely proportional to area. Suppose if area we consider a sphere, for sphere area is 4 pi r square. And why we are writing Q is equal to psi? Q is equal to psi we are writing because as per the Faraday's experiment we have seen that the total amount of charge present in particular surface will be the same as it crosses from that surface in the form of flux. For that, let us consider this example. We have one circuit, say we have R, L and C, and we are connecting one battery to this circuit. So in this circuit, say this is C is electrical component, in that we consider the electrical parameter. This is also passive electric component, and this is L magnetic component. This is battery, this is voltage. Now technically this circuit is correct. This is called as RLC circuit. But what is the condition for a circuit? To form a circuit, we must have a closed path. Closed path is basic condition for a circuit. But here we can see inside capacitor, what is there inside capacitor? There is a dielectric. It may be air, or it may be mica, or any other material. If there is dielectric between these two plates, that means this is open air as per the definition of circuit. So if current passes from there, so if electrons starting from say negative terminal, they are coming here, so they will stop here, because electrons cannot jump inside the dielectric. So they will concentrate here on this place. But still, very surprisingly, what happens? We get equal and opposite charge on the another plate. Whatever amount of charge is there, same amount will be transferred to the opposite plate of the capacitor. What happens? Why it happens? Electrons, these are negative charges, cannot jump inside dielectric. But what they do? They go in some other form. They get converted into something. That something which is crossing from this capacitor, that something we are defining as the flux. This something is nothing but the flux. So how much flux we may get? Say in few books it may be given as psi, or it may be given as phi, right? So psi or phi is the flux. But how much amount of flux will cross this region? Whatever amount of charge is present on the plate, same is going on the other charge, just polarity is changing. That means in this open space, electrons are passing in the form of flux. That flux will be having same amount as charge. So we can say psi is equal to Q. How much flux we are getting? Same amount of charge. Now this is the case of a capacitor. Similarly, we can consider the case of two spheres. So in two spheres, say one is radius A, another is radius B. So if we are keeping them, those two spheres electrically isolated, no connection between them, then what Faraday observed, he gave charge on one sphere only. So he gave, for example, positive charge on the outer sphere, and the central one he isolated. That means there is no connection between the outer sphere and inner sphere. And after some time he removed one sphere. Then what he observed, after removing this sphere, he got automatically negative charge on the inner sphere that was equal and opposite to the outer sphere. So what he concluded, the same thing, either it is capacitor or any coaxial cable or two spheres, there is transfer of something from one charge to another charge from dielectric. That something is nothing but psi, and that value will be equal to charge. So what Gauss law states, the charge enclosed in one place will be equal to the flux crossing from that place. So D can be written as equal to, it directly, what is this? D is flux density, electric flux density. So it is density of flux, or we can also write as charge, because this value will be same, and inversely proportional to, there may be some differential surface, or there may be differential volume, or there may be differential length, right? Now this D is for electric field. Similarly, B is for magnetic flux density. Magnetic flux density will have same relation. This is how we calculate density, cos or creator of that density by area. So who is creating magnetic flux density? Flux is itself. Which flux? Magnetic flux. So we can write here, this is as, say, flux psi or phi divided by area, inversely proportional. If B increases, A decreases. If flux, the creator increases, the effect also increases. So this is about the D and B. Now what is E and H? E and H, we can say, what is definition of electric field intensity? Electric field intensity is nothing but force per charge. Similar way, magnetic field also can be explained as some force on charge. Second, now who creates the electric field and who creates the magnetic field? Electric field is created by direct static charges. Any positive charge or negative charge will also have electric field lines. Say for example, this is a positive charge and this is a negative charge. So now these charges will create electric field intensity. Every charge can be considered as one sun, and they are giving out light in all the direction. These are like point charges. If we extend these point charges, they will look like a big sphere. So for charges, we consider the area of sphere. Okay. So for positive charges, electric field lines go outward and they are all perpendicular to the surface. The diagram is not to the scale. All of them are to the surface. What are these? These are electric field lines, and we can also say these are D lines, because E and D is nothing but D is equal to epsilon E. So in book you may have D in the form of, or you may have equation in the form of E. Negative charges, force lines will come inside. What are these force lines as? Electric field lines as. So who is creating electric field? We can say at the basis of everything there is a charge Q, right? I hope you are understanding this, not getting sleep. So this is the creator of electric field intensity. Now charge also creates magnetic field, but not static charge. Whenever there is a current carrying conductor, that means what is current carrying conductor? Moving charges. These charges are moving inside a current carrying conductor. So this current carrying conductor creates a magnetic field H around that. In few books it is written as it creates B. We can also relate it with B because B is equal to mu H. Okay, so H will be equal to B by mu. So this is about the magnetic field and electric field. Now let us move. This is the magnet. Now this is a permanent magnet. Magnetism can also be created. Magnetism can also be inbuilt in the magnetic material. So if we see the diagram for this, we have two poles, one north pole, one south pole. What we have to remember? The force lines. Here force lines are the flux lines. Here force lines are nothing but flux lines. How they travel? When they are outside the circuit, they travel from north to south. From here bottom also north to south. And how they complete their journey? When they enter inside, they go from south to north. From there also it will go from south to north. Externally they travel from north to south and they complete their circle inside from south to north. So this is the about magnet. One more thing about magnet, it always comes as a dipole. There will be always a dipole. All of us might have played with the magnet in the childhood. Now if we break this magnet, what will happen? Can we separate north pole and south pole? Is it possible to separate? Is it possible to separate? We cannot separate them. Whenever we break them, what will happen? If I make two pieces of this, say here is north pole, so here I will not get north pole only. Again here separate south pole will be created. Here separate north pole and here again separate south pole. Now again if I break them, can I again break and make north and south separately? We cannot separate them. We cannot get single pole. If you make 1000 pieces also, in each piece there will be separate north pole and separate south pole. Are you getting this? So this is about the permanent magnet. As we have seen, H is equal to B by mu. So whenever I am saying H, you have to imagine B. Okay, so formulas will be same. Now let us discuss about B formula more. We'll discuss about mu and the B. Okay, now as we know, any density is equal to cos per area. Now B is also one of our density. So this B can be directly given as psi by A. So what will be the units for B? Now unit for this psi or flux, what is the unit of flux? It is Weber. Unit of flux is Weber. What is unit of area? Say we can give it in some meter square. For example, if it is surface. So what we will get unit for this B? It will be Weber per meter square. Now this is one name of unit. On the name of scientist who studied this concept, it is given one more unit, that is Tesla. So there are two units for this. One is Tesla, another one based on its definition cos per area, it is given as Weber per meter square. And what we have, another parameter, permeability. What is permeability? It is the magnetic field permission, because every material will have different kind of resistance, we can say. Now if suppose some electromagnetic field wave is traveling in some medium. Now according to medium, signal strength will increase or decrease. We can see the mobile phone signal in our phone. Sometimes it gets less, sometimes we get full strength. Why it changes? It may change according to the distance from main antenna, or it may depend on some climatic conditions. If clouds are there, the signal may reduce. Now why it happens? Because it depends on the medium. Now for traveling a wave from one place to another place, a wave cannot behave same way like in air, or while it is crossing a wall, or if you want to communicate from a closed room. It has to cross many obstacles. Every obstacle will have different behavior towards that traveling wave. The traveling wave is nothing but combination of electric field and magnetic field. So these permissions given by various mediums is very important. So magnetic field permissions are called as permeability. How easily they will allow them to travel. So suppose in water, its behavior will be different, in air different, in glass different. It may need to, while traveling our call, the signal need to cross say some mountain for example, or it may get some signboard available on the highways. So everywhere they have to face different mediums. So different mediums will give them different permission. Few will allow them easily, few will allow them with more difficulty. So for magnetic, these permissions are considered as permeability mu. So its mu is, total mu is given as mu naught mu r. Now mu naught value is constant for air. What is this value? It is 4 pi into 10 to the power minus 7. This is the value of mu naught. And unit, now as it is magnetic field concept, there are two concepts. One is epsilon, one is mu. Okay, epsilon is related with electric field, mu is related with magnetic field. Epsilon is related with capacitor, say mu is related with inductor. Capacitor is electric device, inductor is magnetic device. So its unit, epsilon unit is depending upon say some farad per meter, how much charge per meter, and mu unit relates with the inductor. What is unit of inductor? Henry. So it is Henry per meter. The unit for this is say Henry per meter. So what is unit of mu? Mu is Henry per meter. Now mu r for air. What is mu r for air? Mu r for air we consider as 1. Say our mobile phone signal, electromagnetic signal traveling in air, so their mu r we will consider as 1. For different material, like if we are considering some magnetic medium like iron or steel, where we get steel? Suppose some construction is there. In that construction, we put the iron rod, steel. So if our signal is, if you are calling from a room or classroom or house, it will cross the wall. So inside wall it need to cross that steel, or there may be some signboards as we discussed of iron. So these are magnetic material. So if our signal has to travel across them, its permission, relative permission will be not 1, it will be far greater than 1. Are you getting the logic? So magnetic materials mu r will be greater than 1 because they will have different permeability, and for air mu r will be 1. So I hope this concept is clear. This permeability and permittivity and permeability, many students they get confusion. It's very simple. Permittivity related to electric field, capacitor is also an electric component, mu is related to magnetic field unit is related to Henry. It talks about the permission given by electric field, it talks about the permission given by magnetic field. Epsilon is equal to epsilon naught epsilon r, where epsilon r also for free space we consider 1. Epsilon naught is also a constant. This constant value is 8.854 into 10 to the power minus 12. Its unit is farads per meter. Similarly, mu is equal to mu naught mu r. Mu r is 1. Mu naught is a constant value, 45 into 10 to the power minus 7. Unit is henries per meter. Mu r for free space is 1, air. If it has to travel from some magnetic material, it will be greater than 1. The value may be given in example 3, 4, 5, so on. So this is about the basics what we require to understand this subject. What is one more takeout we have to remember? Gauss law, the very basic thing, very simple thing. It says the charge is equal to flux. We have to remember this thing, and if we remember density is equal to cos per area. So it may be Q by S, Q by A, or psi by S, psi by Q. B is also equal to cos per area, flux by area. Right. So with this we will stop this session. In next session we will continue this topic. Thank you. Have a good day.